This webcast talks about converting between polar and rectangular notation. First, we'll talk about starting with a polar notation vector and converting it to rectangular notation. Both of these methods are based on right angle trigonometry. So if we have a polar notation vector with a magnitude of r and an angle of theta, then in rectangular notation, the x component is r cosine theta and the y component is r sine theta. This will always be true as long as you are confident that the angle you're using is in standard position. Let's look at an example here. So here we know the acceleration vector for a rocket. It has a magnitude of 3 meters per second squared and it has a direction of 120 degrees. So if we want to express that acceleration vector in rectangular notation, we have to find the x and y components of the vector. The x component would be the magnitude, 3 meters per second squared, multiplied by the cosine of the angle. So we get a negative 1.5 meters per second squared. And then the y component would be the magnitude times the sine of the angle. So we get 2.598. And so in rectangular notation, the acceleration of this rocket is negative 1.5, 2.598 meters per second squared. Let's look at one other example that kind of highlights the importance of making sure that the angle you're using is in standard position. So here we know the velocity vector of a car. It has a speed of 13.4 meters per second and it's moving in a direction 35 degrees south of east. So I need to find that angle in standard position. So I place the vertex of the vector at the origin and I start at the positive x-axis and rotate counterclockwise until I bump into the vector. So it's shown in green here in this diagram. I had to move 325 degrees around this circle before I ran into this velocity vector. So the angle is 325 degrees in standard position. So when I want to express this velocity vector in rectangular notation, I take the magnitude and multiply by cosine of the angle to get the x component, and I take the magnitude and multiply by sine of the angle to get the y component. When I do this, I get an x component that's positive and a y component that's negative. And that's good because that indicates that this velocity vector is in the fourth quadrant with a positive x and a negative y component. If I had calculated the x and y components using the angle 35 degrees, I would have had two positive components. It would have mistakenly told me that this vector was pointing in the up in quadrant 1, right, with both positive x and positive y components. So always make sure that you are using the angle in standard position. Okay. Now let's talk about how to convert from rectangular notation to polar notation. You will use the Pythagorean theorem to find the magnitude as the square root of the x component squared plus the y component squared. And for the angle, you'll use the arctan function, and it will be arctan of the y component divided by the x component. Okay, this isn't quite the end of it. When you're going from rectangular to polar notation, you must be clear on what quadrant the vector points in order to adjust the angle, because the value that's given to you by your calculator may need to be adjusted. Okay, so remember or recall that if something points in quadrant 1, it has positive x and y components. In quadrant 2, the x component is negative and the y component is positive. In quadrant 3, both components are negative. And in quadrant 4, the x component is positive and the y component is negative. Your calculator gives you the reference angle, which is not necessarily the direction of the vector. That arctan function, it doesn't really know if the x is positive or negative, or the y is positive or negative, and so therefore it's only able to give us the reference angle, and we have to adjust that accordingly. Now, if your vector does point in quadrant 1, then no adjustment is necessary. Just use the value from the calculator. But if the vector is pointing in either quadrant 2 or quadrant 3, then you need to add 180 degrees to the value that your calculator gives you. And if the vector is actually pointing in quadrant 4, you need to add 360 degrees to the value that your calculator gives you. So, quadrant 1, use what your calculator gives you. Quadrants 2 and 3, add 180 degrees to the angle that your calculator gives you. Quadrant 4, add 360 degrees to that angle. Let's look at an example here. So here you're told to drive 3.5 kilometers at 42 degrees. So that is, this first vector. You drive along that direction. And then you drive along a vector of, you drive 4 kilometers in the east and 3 kilometers south. So that's this vector B. So you started here at the end of A, that's where you began your journey, and you end over here at the tip of B. That's where the journey ended. So this vector, which I've labeled C, shows the sum of A and B. And we want to add them, and then we want to convert the answer to polar notation. Okay, so before we can add these vectors, we have to express them both in rectangular notation. Then we're going to add the x components, and we will add the y components to find vector C, and then finally we will convert that vector to polar notation. Okay, so first we've converted both vectors to rectangular notation. Now, since vector A was given in polar notation, 3.5 kilometers at an angle of 42, we have to find the x and y components by saying the magnitude 3.5 times cosine of the angle, and then the magnitude times sine of the angle. Okay, now that we have both A and B in rectangular notation, we can add the x components and add the y components, and we get this resulting vector in rectangular notation. We have now found the resultant vector, but it's in rectangular notation, and this problem asked us to also find it in polar notation. So now I'm going to convert to polar. To find the magnitude, I take the square root of the x component squared plus the y component squared. So I'm just using Pythagorean theorem to find the magnitude of C. And then to find the angle, I take the arctan of the y component divided by the x component. Now I get a negative angle, but when I look at the signs on the components in step 2, I see that there is a positive x and a negative y component. something that has a positive x and a negative y is pointing in the fourth quadrant. And so I want to make the adjustment of adding 360 degrees to the angle that I've found. So in polar notation, the total displacement as a result of this trip is 6.634 kilometers at an angle of 354.307 degrees.